Hello student, good morning. I am Dr.A.K. Sinha, Professor of Chemistry. Today I am going to discuss ionic equilibrium in solution. Last class I have discussed factors affecting equilibrium. Factors affecting equilibrium. In that I have discussed effect of concentration, effect of temperature, effect of pressure, effect of inert gases, effect of catalyst. Now I am going to start ionic equilibrium in solution. Now we will think what is this ionic equilibrium? You have studied now already discussed chemical equilibrium. Then now what is the difference between that equilibrium and now what I am going to start ionic equilibrium. Chemical equilibrium, ionic equilibrium comes under the chemical equilibrium. Then main equilibrium I have discussed. Then now we will think what is ionic equilibrium. Then just I am telling the difference. You have seen that the production of ammonia from nitrogen and hydrogen, N2 plus 3H2, it gives 2NH3. Then here you have seen nitrogen and hydrogen. Both are reacting and giving ammonia, means NH3. They are not in ionic form. They are in a molecular form. Nitrogen, molecular form. Hydrogen, molecular form. Product, ammonia, that is also molecular form. Next example I am giving you H2 plus I2, 2HI. Then H2 is molecular form, I2 is in molecular form, HI is in molecular form. Okay. Decomposition of PCl5. PCl5 it gives PCl3 plus Cl2. Then PCl5 is in molecular form, PCl3 is in molecular form, chlorine is in molecular form. Next example you can take N2O4. Decomposition of N2O4, it is giving 2NO2. Then all are in a molecular form. But here what we are going to study, that is not in molecular form. That is ionic form, like H plus, Cl minus. Like that way, thiocyanate ion, ferrous ion, what I discussed, all are ionic form. Then many reaction takes place in the ionic form. Ion, cation and anion, they will be in equilibrium. Okay. Then means after reacting also means all reactant will be in ionic form and product form will be also in ionic form. As for example, last class I have discussed already. Now again I am telling you ferric ion, Fe3 plus aqueous ferric plus aqueous thiocyanate HCN. It is giving complex in ionic or ionic complex, that is a FeHCN. Charge is plus 2, ion is 2 plus. Ferrous thiocyanate ion as a product. Then all three are in the ionic form. And these reaction is also in equilibrium. Then many reaction takes place in ionic form. That's why now we are studying ionic equilibrium in solution. Generally ions will form in solution only. That's why it is studied or heading is given ionic equilibrium in solution. Under the effect of change of concentration on the direction of equilibrium, already you have studied direction of equilibrium. Under the effect of change of concentration on the direction of equilibrium, already you have incidentally come across with this reaction, means ferric plus thiocyanate, ferrothiocyanate. Already you have seen that this reaction is in equilibrium. There are numerous equilibrium, many equilibrium that involve ions only. Here in this topic, you will study the equilibria involving ions. It is well known that the aqueous solution of sugar does not conduct electricity. Why? However, when common salt like sodium chloride is added to the water, it conducts electricity. Sodium chloride, when you will put in water, then its solution will conduct electricity. But sugar C6H12O6, that is a glucose and fructose, and C12H22O11, that is the sucrose. Then glucose, fructose and sucrose, it will not conduct electricity if you will put in water. Why? Why sodium chloride solution conduct the electricity, potassium chloride conduct the electricity? Means all ionic, you can say salt will be generally ionic only. Not generally, it will be ionic only. Salt, NaCl, KCl, H3PO4, calcium sulfate, calcium chloride, potassium chloride, cation anion. Wherever cation anion will be there, they will conduct electricity. Because they have charge in ion, they are free to move. And either cation and anion, they are free to move. If you pass the current, then suppose this cathode and anode you have introduced in the solution, current you have passed, then they will move in opposite direction. Anion, which is negative charge, it will go to the, you can say, positive electrode, and positive will go to negative will go to the positive, means cation and anion. Cation is positive charge, it will go to the cathode, which is negative charge, and anion, which is negative charge, it will go to the anode, which is positive, opposite direction. See, but this is not possible in case of glucose and fructose, sucrose, because they are not dissociated in ionic form. They are not dissociated in ionic form. They are not exist in ion form. That's why almost all organic compounds, they will not conduct electricity on dissolving in water. That is, the aqueous solution of organic compound will not dissolve electricity. But ionic compound, electrolyte, this is also called electrolytes, okay, because it produces cation and anion. That's why it is called electrolyte, or also ionic compound. They will conduct electricity. Okay, these very important things I have told you. Question is asked also. Okay, and then by seeing all the things, Faraday classified the substances into two categories based on their ability to conduct electricity. One category of substance conduct electricity in their aqueous solution and are called electrolytes, while the other do not conduct electricity. Then that will be called non-conductor, non-electrolyte. Okay, one category is called electrolytes, while the other do not, and are thus referred to as non-electrolyte because they are not conducting current. Faraday further classified electrolytes into a strong and weak electrolyte. A strong electrolyte and weak electrolyte. A strong electrolyte on dissociation in water are ionized almost completely, 100% it will ionized. Okay, they will convert into the ion form. Unionized will be not there. All fully it will be ionized. Then one category is a strong electrolyte and other category is weak electrolyte. Weak. Okay, a strong electrolyte on dissolution in water are ionized almost completely, while the weak electrolyte are only partially dissociated, not fully. 70%, 60%, 50%, and rest will be in unionized form. That's why there will be equilibrium between unionized and ionized. Always there will be equilibrium between unionized and ionized. As for example, simple example I am telling you, if you can say some stone-like substance you will put in water, then you will find some particles will dissolve. A stone, some particle will dissolve, rest will be in the solid form. Okay, then there will be equilibrium between this solid, that is unionized, and few atoms or molecules only it is dissolved, few. Correct? Then there will be equilibrium between this ionized and unionized. Solid is called unionized. Then there will be equilibrium. Okay. Then other example, common example I am telling you, H2O, water. It is you can say it will not ionized fully, feebly ionized. Feebly, Feebly, feebly ionized. Means most of the water H2O, they will be unionized. Only few will dissociate into H plus and OH ion. Okay. Then there will be equilibrium between unionized water and ionized water. Unionized and ionized. Suppose you have taken 100 mole of water. Then in that you will find only you can say 1 mole is only 1 or 2 mole only is dissociating. Rest majority of waters are not dissociating. That is called unionized. Unionized. Then always there will be equilibrium. Then here you are going to study this type of situation only. Then I told you that what Faraday you can say classified substances, electrolyte, they have classified into two, a strong and weak electrolyte. A strong electrolyte and weak electrolyte. A strong electrolytes on dissociation in water are ionized almost completely, while the weak electrolytes are only partially dissociated. For example, an aqueous solution of sodium chloride NaCl is comprised entirely. Sodium chloride is comprised entirely of sodium ions and chloride ions. It will dissociate fully in sodium and chloride ions, while that of acetic acid CH3COOH, acetic acid. Okay, this acetic acid you can say it will ionize very less. Okay, while that of acetic acid mainly contains unionized acetic acid molecules, and only some acetate ion are hydronium ions. Okay, because it is acid, then but it is very weak acid, it will produce very less H ion. Then this H ion very slightly it will dissociate, very slightly. Weak acid. Weak acid means it will give hydrogen ion very less. In water it will dissociate very less. Most of the acetic acid will not dissociate, only less will dissociate, and it will give acetate ion, means CH3COO minus plus H plus. Acetate ion, acetic acid dissociates like that, CH3COO 1 minus plus H plus. But only very less acetic acid will dissociate like that. All acid will be undissociated. Then here what will happen? Here important thing again I am telling you. that because it is dissociating in water, then water is H2O, then this H2O plus H plus, this H2O plus H plus coming from the acetic acid which is dissociated, then it will form hydronium ion H2O plus H plus, then H3O plus, okay. But this will be H3O plus you are writing, but delta plus you can tell, because less charge will be there, just like a hydrogen bonding, same situation is there, okay. Then it is called hydronium ion H3O plus, plus is because H is coming as a H plus and H2O is neutral, then because weak bond will be there, they will make a weak bond for H plus, that's why it is called H3O plus. This plus is due to the H plus. Then that H plus ion given by acetic acid, that is now just joined with H2O and form hydronium ion. Okay, then here I told you that acetic acid mainly contains unionized acetic molecules and only some acetate ions and hydronium ions it will give. Okay, hydronium ion, because H will quickly react with water, will make bond, it will form hydronium ion. Then in water, very less acetate ions and hydronium ion will be there. This is because there is almost 100% ionization in case of sodium chloride. In case of sodium chloride, 100% ionization will take place. No solid will remain. As composed to, you can say, less than 5% ionization of acetic acid. But acetic acid only 5% will dissociate. 95% will be in the acetic acid form. Only 5% acetic acid it will dissociate into acetate ion and H ion. Okay, 5% ionization of acetic acid, which is a weak electrolyte. Always weak electrolyte will do like this only. 5%, 10%, 3% will ionize. Rest will be in the unionized form. It should be noted that in weak electrolyte, equilibrium established between ions and the unionized molecule. Okay, already I have told. Now again I am telling you that there will be equilibrium will be established between ions and the unionized molecules in weak electrolyte. Okay, always it will happen in weak electrolyte. Equilibrium is established between ions and the unionized molecules. This type of equilibrium involving ions in aqueous solution. Aqueous solution means you have salt you have added in water, acid you have added in water. Water is called aqueous. That's why it is forming solution. Salt plus water. Salt is a solid. Water is a solvent. Then solute also it is called solute. Salt is also called solute. The solute plus a solvent. Water is a universal solvent. Then it will form solution. Then solute plus a solvent is equal to solution. Always keep in mind. In physical chemistry, always you think like that, solution. Main things I told you, that solute plus a solvent is equal to solution. Then here equilibrium will be there between the ionized and unionized. Equilibrium will maintain the equilibrium. Okay, unionized and ionized. This type of equilibrium involving ions in aqueous solution is called ionic equilibrium. Okay, acid, bases and salts comes under the category of electrolytes. These are also called electrolyte. Acid, all acid bases, salt, these comes under the electrolyte. These are called electrolyte. Why? Because acid also, just like HCl, it will give you H plus Cl minus. HNO3, nitric acid, H plus NO3 minus. H2SO4, 2H plus SO4 2 minus. 2H plus, it will give 2H ion. 2H ion, 2H plus SO4 minus minus. Then see, all are acid. That's why it is called electrolyte. All are producing ion, cation and anion. Same way, bases like NOH, KOH, calcium hydroxide. NOH will produce Na plus OH minus, means cation and anion. NOH, Na plus OH minus, KOH, K plus OH minus. Calcium hydroxide, Ca2 plus 2OH minus. Then these are bases and they are producing ions, cation and anions in water. That's why it is also called electrolyte. And salt like NaCl, KCl, calcium chloride, potassium chloride, they will dissolve in water and it will form K plus Cl minus, Na plus Cl minus, calcium chloride Ca2 plus 2Cl minus. Okay, like that way these salts are also producing cation and anion. That's why it is also called electrolyte. Then acid, base and salts are called electrolyte. Understood? Now I am going to discuss about acid, bases and salts, because they are also electrolyte. They are also electrolyte and they will be in equilibrium. They will maintain the equilibrium depending upon whether it is a strong or weak electrolyte. Okay, acids are strong or weak, bases are strong or weak, salt is strong or weak. Okay, mixed salt, that is also called mixed salt, like a sodium acetate. Then here only I want to tell you salts. Sodium acetate, CH3COONA. Sodium acetate means acetic acid was there, CH3COOH. Then H replaced with sodium. Generally salt will form when acid and base will react. Acid and base when reacts, then it forms salt plus water in general. This you don't forget. Acid plus salt, when it will react, it will form salt plus water. Example, I am giving you acid like Cl, base like NOH, HCl plus NOH. Then H, they will react opposite charge. HCl is HCl, then H is positive, NaOH, OH is negative. Then H plus OH, it will form H2O, and Cl is negative, and Cl is negative and Na is positive. Opposite, they will react in opposite sign. Then it will form NaCl. Cl plus Na, NaCl, both are opposite charge. Then see, HCl plus NaOH. HCl plus NaOH, when they will react in water, then it will form NaCl plus H2O. NaCl is here is a salt, and water, H2O. Water is feebly ionized, very less ionized. But here again I want to tell you that when a strong acid reacts with a strong base, strong acid, when it will react with a strong base, then it will form a strong salt like NaCl, because both Na and Cl came from the strong. Na came from the strong base NOH, and Cl came from the strong acid. HCl. That's why salt will be strong, and in water it will ionize 100%. Like that, the same situation is for KCl. KOH plus KOH is base, KOH is base plus HCl. HCl is strong, both are strong. Hence again it will form KCl plus H2O. Then KCl is strong. Then like that way, if one is a strong acid and other is a big base, suppose acid base, acid is strong and base is weak, then that time also it will form salt plus water, means H2O. H2O is common. But here salt will be weak. Salt will be weak because suppose I am telling you sodium state, already told you, sodium state is example of weak salt. Then see, sodium acetate, then acetate is coming from the acetic acid, which is a weak acid. But Na is coming from a strong base, okay. Then it will in water, Na will form, in water it will form NaOH, but CH3COO acetate ion will form weak acid, acetic acid, okay. Then this I understood. If anyone is weak, acid and base, if anyone is weak and other is strong, then they will form weak salt, okay. And water always it will form, because H ion, OH ion, they will react. In acid, H ion will be there, and in base, OH ion will be there, okay. Then here main things I have told you. Now I will tell you somewhat details, okay, because question is asked. Many questions are asked on this concept. Actually, acid, bases and salt, it comes under the inorganic chemistry. But here you are studying with physical chemistry. Why? Because here you are considering ionization. That's why here it is studied. Here all things will be studied. Here you will study acid, base and salt. Here you will study buffer solution. Here you will study pH of the solution. Here you will study common ion effect. Why? Because the same reasoning, because all things are related with ions. All what I told you, acid, base, salt, buffer solution, pH solution, okay, all are related to ions, particularly H ion and OH ion. That's why here you are also studying acid, base, salt, buffer solution, pH, okay, common ion effect, all are related to ionization, okay. And now I am telling about acid, base and salt. Acids, base and salts find widespread occurrence in nature. In nature it is found. Hydrochloric acid present in gastric juice is secreted by the, you can say, lining of our stomach in significant amount of around 1.2 to 1.5 liter per day. This acetic acid is forming in our stomach body. Daily it is forming 1.2 to 1.5 liter per day. That's why it forms a gas in our body and is essential. It is used actually. This liter, what is happening? This 1.5 liter, 1.2 liter, it is forming in our stomach. Then what is its use? Then it is essential for digestive process. Food digestion, it is used in food digestion, digestive process. Acetic acid is known to be main constituent of vinegar. Question is also asked, okay, for any objective question, any examination. Acetic acid around 10% to 15%. Okay, little variation is there. Acetic acid is known to be main constituent of vinegar. Lemon and orange, lemon juice and orange. Lemon and orange juice contains citric acid and ascorbic acid. Question is asked. All are very important. Lemon juice and orange juice. Then lemon juice citric acid and orange ascorbic acid. Lemon and orange juice contains citric acid and ascorbic acid, and tartaric acid is found in tamarind paste. Tamarind, there in kitchen you are using tamarind also. Then here in tartaric acid you will find in tamarind paste. Okay. As most of the acid taste sour, S-O-U-R. What is the taste of acid? Most of the acid. Then as most of the acids taste sour, the word acid has been derived from a Latin word acidus. Acidus means sour, S-O-U-R, sour, meaning sour. Acids are known to turn blue litmus paper red. Okay, again always you remember, these are common things. Acids are known to turn blue litmus paper into red. Then opposite will be base will be opposite. Acids are known to turn blue litmus red. Okay, and liberate dihydrogen means H2 on reacting with some metals. Generally, acid when reacts with metal, any metal, then it liberates H2 gas, hydrogen gas. Okay, this also don't forget. Then acids on reaction with metal, it liberate dihydrogen means H2 on reacting with some metals. Similarly, bases are known to turn lead litmus paper blue, opposite of acid. Bases are known to turn red litmus paper blue. Okay. And its taste will be bitter taste. Base taste will be bitter and it will be soapy. It will slip. You have seen in the bathroom soap. You can't, if you not hold particularly, it will go out. Soapy. Then base, it will be bitter and soapy. Feel soapy. A common example of a base is washing soda, sodium carbonate, washing soda, used in washing purposes. And there only here I want to tell you, for advanced knowledge, there are two, you can washing soda. Washing soda, that is this for the washing purpose you are using, and for bathing, this is for washing. Washing soda is used for cleaning purpose, washing purpose. But for bathing purpose, potassium, and that is a fatty acid, potassium salt of fatty acid. Potassium salt of fatty acid. This is salt actually. Soap is a salt. Soap is a salt. That is salt of what? Then potassium and fatty acid. Potassium is coming from the base KOH and this fatty acid. Then this potassium salt of fatty acid is called actually bathing soap. bathing soap, and sodium salt of fatty acid. In both cases fatty acid is there, but if potassium is there, potassium salt of fatty acid, then it is used for bathing purpose. Bathing purpose. And if sodium salt of fatty acid is there, sodium, then it is used for washing purpose, cloth wash. Okay, you are cleaning the cloth, no, for that, for the body wash, bathing soap. I told about this soap also here. In advance I told you. Now again I am continuing. A common example of a base is washing soda. Already I told you, used for washing purposes. When acids and bases are mixed in the right proportional, they react with each other to give salts. Okay, already you have discussed. Some commonly known examples of salts are sodium chloride, barium sulfate, sodium nitrate, sodium chloride. Sodium chloride is also called common salt. Sodium chloride is also called common salt. Okay, then also called table salt and common salt. That is the sodium chloride. Then this I have given the example. This table salt, sodium salt, daily we are using salt in our food. That is the common salt or table salt, because always it will be present on table, dining table. That is called table salt also. Also called common salt. And that is a common salt is an important component of our diet and is formed by reaction between hydrochloric acid, means HCl, and sodium hydroxide. That is the base. And already I have told you. Okay, HCl plus NOH, it will form NaCl plus water. Then it exists in solid state. Sodium chloride, means common salt, exists in a solid state as a cluster of positively charged sodium ion and negatively charged chloride ion. In NaCl, sodium will be positively charged, chloride will be negatively charged, which are held together due to the electrostatic interaction between opposite charge, especially because one is positive charge, other is negative charge. Then force will work between the two. That is a electrostatic interaction, electrostatic force between oppositely charged species. The electrostatic forces between the two charges, means opposite charges, are inversely proportional to dielectric constant of the medium. Here you have to understand the electrostatic forces between the two charges like Na and Cl, one force, attractive force is working. Then this force is there between the two, electrostatic force or attractive force is there. If you will put in water, then whether it will dissolve or not in water, it depends upon the dielectric constant value of medium, means like water. Water is the universal solvent. Why it is universal solvent? Many things will dissolve in water due to this property. Water has, you can say, high dielectric constant value, around 79.9. 80 you can tell roughly dielectric constant value. Water dielectric constant value is roughly 80, 79.9. Then what is dielectric constant value? Then here you can see water is also H plus OH minus. They have positive and negative charge. Then they have capacity to attract oppositely charged ion, which will be dissolved in water. If any salt, any things is going to dissolve in water if they have positive negative charge like a salt, then this water will attract oppositely H plus. This positive charge will attract negative, like NaCl was there, no, Cl is a negative charge. Then H will attract Cl, and this OH minus that will attract positive, like Na plus. NaCl is there, na? Then it will dissolve. It will ionize in water. Because Na will be attracted by OH and Cl will be attracted by H. Then they will form HCl and NOH. It will form HCl, H plus Cl, H plus of water, Cl from the salt. Then it will form HCl and OH from water, Na from the salt, NaNOH. Then it will form, because both are strong, hence it will form neutral salt, a strong salt. Okay. Then, but it will attract. This attracting power of water is called dielectric. Di means two, dielectric. Then di means two, electric means charge. Then water has positive and negative charge. That's why anything if you will add in water, it will dissolve. It will dissolve. Due to this property, water has capacity to dissolve many things. Water, that is called water soluble. Substances are called water soluble, and some things are there that will not dissolve in water. That is called insoluble. Insoluble. Even you might have seen that in rainy season, in rainy season, what will happen, that pitch road they will make, newly constructed road. If in that road water will, you can say, if in rainy season, if on the new road, water will be collected full, dipped in water, that road. Then what will happen, that road will be, you can say, completely, it will be, what will happen, it will break. It will actually all in pitch, whatever material is there, that will dissolve in water. Then road will be destroyed. Pitch road will be destroyed because water has capacity to, you can say, ionize. If in pitch some materials are there, water soluble things are there, all will dissolve, and road will destroy. It will break into so many pieces. Okay, slowly and slowly, this it will ruin the road completely. Okay, this is the reason why after the rainy season, road will breaks. Okay, you will find in so many pieces it will crack. This is the main reason. Then now I have told about the this things, dielectric constant of water. It is 80, 79.9, roughly 80 you can tell. Then now understood the meaning of dielectric constant value. Then here again you think, because in IIT mains or advanced question is asking, that's why all things I am telling you. Then, or even in UPSC examination also. Okay, UPSC, CSIR, Net, this type of question they are asking. Then now here again one important thing, sir, I want to tell you that organic compound means, you can say, they will be covalent compound, generally covalent, and they will be non-polar. Non-polar means no charge. As for example, sucrose, I told you, glucose, fructose, all the things. Generally organic compounds will be non-polar. Polar means little charge. Little charge will be very weak positive, very weak negative charge. That is called polar. And non-polar means it's almost no charge, very negligible negative and positive charge will be there on a non-polar. And polar means little more but not like ionic compound. Not like ionic compound or electrolyte. Electrolyte and non-electrolyte, there will be, you can say, more positive charge, more negative charge. But polar means here you are talking about less positive, less negative. Delta positive, delta negative. Non-polar means negligible. Charges will be there, very less. Okay. Then now I am telling you that organic compound generally will not dissolve in water. Why? Because they have very less charge, Then because they have very less charge, positive, negative charge, that's why they will dissolve very less. Polar will little dissolve, but non-polar will not dissolve, or if it will dissolve, very less, negligible. But electrolyte will dissolve in water, fully it will dissolve, because electrolytes are ionic and water is also have positive, negative charge, hence it will dissolve. But now organic compound will dissolve only in organic solvent. Organic will dissolve. Inorganic will dissolve. But cross will not dissolve. Means organic substance will not dissolve in inorganic. Inorganic substance will not dissolve in organic. Then organic and inorganic difference is there. Organic means covalent bond will be there. Charge will be less charge. Non-polar further very less charge. But inorganic means here there will be charge. Cation, anion, more charge will be there. That is called inorganic substance. Inorganic means always think positive and negative. Positive and negative charge. Full positive, full negative. But organic means there will be very less positive charge, very less. It will not dissolve in water. Okay. Then organic substance will dissolve in organic solvent. Then organic solvent means ethyl alcohol, methyl alcohol, carbon tetrachloride. Both are organic compound. Then they are fit. Inorganic is fit for inorganic. Organic is fit for organic. Because both are of the same nature. Hence it will dissolve in the same. Okay. This you keep in mind. Then now I have told you about the water. Okay. Thus, when sodium chloride is dissolved in water, the electrostatic interaction are reduced by factor of 80. Means this water will reduce Na and Cl. Bond was there now, attractive force was there. Then because its value is a dielectric constant value of water is 80, then NaCl force which was strong, that will become 80 times weak. This is the value of important of dielectric constant. That NaCl in the beginning it was strong, more force was there, positive and negative, they were strong. But in water that force become 80 times less due to the water, because they will attract oppositely charged. Hence their Na and Cl which was the strong force, that will 80 times its force will reduce, will become less. That's why it will dissolve. Okay, this again very important things I told you. I think you have understood the meaning of dielectric constant value. Every solvent has dielectric constant value. Okay, maybe less, that is possible. Some maybe have very less dielectric constant value, some maybe 30, some maybe 40, 50, 10, 5. Then now think which have 5 or 10, then how they can't lose the bond between the Na and Cl. Okay, this will not lose the bond. Bond will be strong only, that's why it will not dissolve. That's why inorganic salt will not dissolve in a organic solvent. Organic solvent, it will not dissolve because organic compound will have less dielectric constant value. And same things that inorganic salt like NaCl will not dissolve in organic. Organic because have less dielectric constant value. Okay. Then organic compound in inorganic solvent like acid HCl, HNO3, H2SO4, it will not dissolve because that organic compounds are not fully charged, they are very less charged, that's why it will not dissolve. Okay, this I have discussed, very important things. Also you can say they are well separated due to hydration with water molecules. And one more factor why it is dissolving like NaCl, KCl in water, then other more important thing is there, hydronium. This H ion will be, you can say, attracted by H2O molecules, not by H plus and OH minus charge. That is the ion. H2O itself will just come across the Na everywhere, sphere form. Na is there, Na plus, there everywhere. Everywhere you can say H2O will come. Actually everywhere H2O, in the middle Na will come. Like that way, Cl, that everywhere H2O, Cl will come in the middle. That is called hydration. Hydration means water, H2O. Then see, this is due to this property also, you can say many things dissolves. NaCl, KCl, H2SO4, barium chloride, all salt, okay, which are ionic, it will dissolve in this way. Then two reasons are there. First, dielectric constant value, and second, hydration. Direct H2O is covering. They will cover ion, cation and anion. Cation and anion will come in the middle and everywhere H2O. Cl also, that will covered by everywhere by H2O. Then how you will ask the question, why it is like this? Then here think, because H2O, that is the, you can say, have negative and positive charge both. Okay, electronegative, oxygen is electronegative and H is electropositive. Hence, due to this electronegative property of H2O, O is electronegative, then they will attract opposite. Like Na plus everywhere. Okay, not by that attracting, due to the, in H2O also directly without breaking also have some electronegative property, and that's why everywhere H2O will try to attract that sodium. Then many H2O will come and all will try to attract that sodium. Then they will form a sphere. Just like everywhere in the middle, sodium will be there. Same way, chloride ion. Everywhere H ion wants to attract, then so many H2O will be there. They will come and try to attract H plus will try to attract negative, and it will form a sphere. Actually, these things you will study in higher classes. Okay, same concept, that is in BSc, even in MSc also. There is different terminology is there, but main things I have told you at this level. Sometimes IIT advanced, this type of question is asked. Okay, then I have told about the solubility, that is called, here in this chapter also we will study solubility, because all are related to ions. Okay, then now I have told you about these things, how you can say salt dissolves in solvent. Okay, comparing the ionization of hydrochloric acid with with that of acetic acid in water, we find that if we will compare ionization of hydrochloric acid with that of acetic acid in water, you are comparing, then now you are knowing hydrochloric acid is a strong acid and acetic acid is a weak acid. And big base example is ammonium hydroxide. Don't forget, ammonium hydroxide, NH4OH, that is the weak base. Okay. Then acetic acid, if you compare with hydrochloric acid in water, we find that though both of them are polar covalent molecule, former means HCl is completely ionized into its constituent ions, while the latter means acetic acid is only partially ionized, only 5%. The extent to which ionization occurs depends upon the strength of the bond and extent of solvation, two factors. The extent, how much it will dissolve, the extent to which ionization occurs depends upon the strength of the bond and the extent of solvation of ions. Solvation of ions produced, how much ions are produced, okay, in these two factors. The terms dissociation and ionization both have different meaning. You should not confuse. The term dissociation and ionization, already I have discussed, both are different with different meaning. Dissociation means refers to process of separation. As for example, you can say you have taken a lump of, you can say NaCl, a lump, big solid, you have taken NaCl. Then NaCl is already ionized. Ionization means, already I told you, that is the from the neutral atom. If electron is coming, then it will form positive cation, it will form because electron went outside. And if a neutral atom will take the electron, then that will form negative ion, means cation and anion. If electron is accepted, then anion it will form. Molecule is accepted negative, then anion. Neutral atom accepted the electron, then it will form anion. Neutral, both are neutral. Then one neutral atom lost, you can say given the one electron, given out, lost. Okay. Then that form positive cation, and other atom, neutral atom, take an electron, then it form negative charge. That is all anion. Then that is actually, this is called ionization, formation of ion, either by losing or gaining the electron. That is called cation anion, and that process is actually ionization. But what is this dissolution? What is this dissolution? Dissociation? Then here, suppose NaCl is there, Na plus Cl minus, then both are close actually. Then suppose many NaCls are coming close. They are making a bulk particle, big particle, solid. Then this solid, if it will dissolve in water, then all NaCl, which were NaCl molecule, all were close to each other. NaCl, many molecules were there, NaCl, many molecules were there. Then when you will put in water this lump, solid, then what will happen after some time, or if you will shake it, then all will be separated out. All NaCl will be separated out. Then that is called dissolution or dissociation. This is the difference between the ionization and dissociation. All NaCl, many NaCl was there, all were collectively they were associated, but now all went far from each other, separate, and that is called dissociation. Okay, all you can say solubility, dissolved. Okay, dissolution or dissociation or solubility. Okay, means dissolved. Then this I have discussed. Okay, then I already told you that ionization correspond to a process in which a neutral molecules splits into charged ions. Molecules also can split into the charged ions. Okay, the neutral molecules split into charged ions in the solution, and then that is I told you about the ionization and dissociation. Ionization correspond to a process in which a neutral molecule splits into charged ions, means formation of charge in the solution. Okay. And now I have told you about the these things, acid, bases and salts. In that I have discussed mainly on the related, that is these things, dissociation. We have discussed about the dissociation. Okay, and now next class I will discuss more about the acid, bases and salt. Okay, today I am stopping only here. Thank you.